got 2 votes for that? We got 3 votes. Sounds like a groundswell. All right, so here's why I think I was suspecting this first one. Let's just think about it in terms of if it's going 18 meters per second upwards at this point. Just as a really, really crude estimate, if that velocity were constant, it would take more than 2 seconds to reach this far. If I projected it upwards. Now it's gonna start out faster than that and slow down as it goes, but it just didn't feel like if it's going 30 meters per second at that point that it would be under 0.2 of a second to get here. Sort of looking backwards, thinking about this aspect of it. So the question is, it almost seems like there's a similar mistake here. Did you remember this negative right here? And that negative goes away because you square it.
Yeah.
So what's the discriminant here?
Oh, I see my problem.
Oh,
Yeah.
what'd you do?
I didn't put parentheses for that negative 18.05.
You just divided the second part like this.
No, I put it all in like that first one.
Oh.
And then, but I didn't put the parentheses because it's a negative. So when it's negative number, I think you have to put the parentheses.
Oh,
when you're
oh, oh.
squaring it.
So you intended to have the negative squared, but,
Yeah,
Did
but
not.
it was just negative
Okay.
18.05 to the,
okay,
yeah.
Oh, yeah.
okay,
Got it.
All right, so then there was some other error there. All right. So we've got these 2 times here, which is the correct time.
Oh,
Bless you. All right. Oh, sorry, Ibrahim, I cut you off several times here.
I wrote the wrong, so instead of writing, 4.435 for inside the square root, I just wrote, 4.35. So, and then on top of that, not having parentheses gave me a goose of an answer.
And the moral of the lesson is?
Parentheses matter.
Okay, there's another lesson?
I got a goose of an answer.
That's it right there. I was gonna go with show your work.
Okay.
All right, we now have enough information, we can solve for R. What equation are we gonna use to solve for R?
The second one.
Oh, okay. We don't need this anymore. Oh, we can squeeze it in over here. Plenty of room. All right, so plugging into that same equation right there, we have R is equal to 23.969 times 5.66 plus 0. Somewhere around 120. Five times that puts that does a bit more. That puts so about 129.
Ooh. 135.66. Mental math ain't as sharp as it used to be, huh, Mr.
Would that be meters?
I have good days and bad days.
Would it be meters?
It would be. Thank you. And there we have an answer.
Rejoice, we just did physics. You did, you're done.
Caroline?
This might be a dumb question. Okay, so I understand that when we were solving for R, we were using like the I hat side of stuff.
Right.
But why solving for time?
Because this is the information, this, basically, if I consider how fast it's thrown up into the air, that's going to limit the amount of time it's in the air. Just like when I shot it horizontally, the problem we did Tuesday, we shoot it horizontally and drop the ball at the same time. We used the vertical to figure out how long it was in the air. There's not enough information here to figure out how much time it's in the air.
Oh, okay, never mind, now I see it.
All right, other questions before I make it a little more difficult? No, let's just, truth of it, before I make it more difficult, not just look more difficult.
Are we gonna find the final velocity?
We can.
Do it.
Let's do it. What the heck? How do we find final velocity?
Final velocity, third one.
Okay, am I doing vertical or horizontal?
Either one, so we could do, we'll do vertical first.
Okay,
Wait, no, wouldn't it be just the same? Okay, hold on. So for horizontal, it's gonna be the same as the initial.
yes,
So let's do vertical.
good call. So this is 23.96. Again, acceleration is 0, which means there's no change in the velocity horizontally. All right, so we stick in the vertical stuff. You mentioned the third equation, we can go for that one. So I've got V final, and this is vertical. Is equal to negative 18.05 plus 8.87 times 5.66. $27. Underestimated again. 32 point what?
1542. Meters per second.
All right, so we've done the hard work there. We now actually have to answer the question, what is the final velocity?
Add them and divide by 2. And no being silent means that it's wrong.
You said add the much, wasn't quite sure what your word, add.
No, that's your final velocity. Wait, so that isn't the final velocity for that? Vertical?
That's vertical, yes. But the question is, what's the final velocity?
Well, see.
We've done the hard part, it's just a matter of presenting.
Final velocity is.
Did you just do 23.969 meters per second? I had, was it plus or minus, I don't know.
Minus.
All right, so let's think about this. What did we solve over there?
So we solved time on the yellow, then we solved.
Yeah, sorry, let's be more specific. What does that number mean?
That is the final velocity, that's the final velocity for what it took to make it vertical.
Okay, along the right lines. All right, is this positive or negative?
Positive.
Yeah, it better be the same over there.
Okay.
This is a velocity, or a velocity component, it's not a speed. So this should be telling us that it's positive. Also, when it's hitting down like this, which means that you've got an I hat component, which is positive, and a J hat component, which is positive. Because we said down is positive. Plus, 32 point, whatever it was. 1542 meters per second J hat. All right. So if all I asked is what's the final velocity, boom, done. Or I guess combine them, boom. If I asked what's the final speed, what would you do?
I would plug it into
This one?
the speed scale.
Okay, we can do that. Let's do it. And then we'll do it differently. So VF squared equals, what's VI in this case then?
Oh. Well, it's not that one, but more you can say.
Would that be the initial speed, which would be
30 squared plus 2 times, this is where you get the dot product aspect of it. What is the direction of the acceleration?
Down.
Okay, so the only part that's gonna survive from this multiplication is the downward piece of it. We can do it more formally, 0 I hat plus 8.87 J hat dot my displacement, which we now know is somewhere over there. I didn't actually write it down, I've erased it.
The displacement is,
It was 135.66 I hat plus 40 J hat. Personally, I don't find this the easiest way to find the final speed, but it is legitimate. So now when I'm doing the dot product, I multiply the I hat pieces together, 0. I multiply the J hat pieces together, I get something magical. So this is equal to 900 plus 2 times 8.87 times 40. Like 350?
354.
354.
0.8.
1254.8. And so VF is the square root of that, which is 37-ish,
35.423.
35.243
What, 423?
units.
Meters per second.
It would be. All right. Oh, sorry. What's a different way to get the exact same answer? What I assume will be the exact same answer.
text Dr. Fox. And hope he answers.
Let me word it differently. I gave the velocity, the final velocity over there is in rectangular form. If I asked you to put it in polar form, what would you do?
Oh. Just, final velocity equals, parentheses, 23.969 meters per second I have, comma, 32.1542 meters per second J hat.
Yeah.
Not at all.
Not at all. What is polar form? What information is given to you in polar form? All right, and I heard direction.
Direction and magnitude?
Yeah. So the final speed is just the magnitude piece of it. So, I have over there, I've got 23.969 going to the right, and then I have 32.1547 something.
4.2.
Going down. My magnitude is a vector from where we began to where we ended. How would you find the magnitude of this piece?
A squared plus B squared equals C squared.
So hopefully 23.969 squared plus 32.1542 squared, and then take the square root of that, is equal to this.
Oh, wow.
And is this number right?
What's making you question yourself? Or us, but you know, exactly.
All right, if I just do crude estimates here, I have 4 times 9, which is 36, times 2, which is 72. I was wondering if this is off by a factor of 2.
Oh, yeah, because I didn't multiply 2 by that.
Okay. Which changes that number, which changes that number. What was alerting me to it is the fact that I was pretty sure that was not gonna add up to 35 point something. Or this was not gonna get me 35. Right. Somebody has just solved something. Who's brave enough to speak first?
So the final answer is 40.12 meters per second.
Did you do it this way or the other way?
I just added the 900 plus 700.
Okay, you did it this way and you ended up with, all right, so we've got that, and if you do it this way?
We got 40.10
Okay, so this way you got 40.10.
meters per second.
Close enough. All right. And then if you found the direction, we do a little trig here, so if we, so that would be our tan of 32.1542 over 23.969, and it's something over 45 degrees.
Now I see why your quizzes are up to 2 questions. Because we have like 30 problems like this one.
That would be brutal.
That would be brutal. No ideas given. In and out, you know.
Just to, you know, like a general rule that on tests, after 4.5 hours, I'm taking it up. I haven't had to do that in a while, I've gotten better.
What, at making tests or teaching?
And it was an evening class at 10 o'clock. A little after, it must have been about 10:30. 10:30, I said, all right, I gotta go home, I'm tired.
Was the kid done or?
It was a 251 class. 251 students will stare at a problem for a half hour, not writing anything, hoping for epiphany.
Yep.
At the other extreme were 110 students who too often we'll look at it, I don't know how to do it, move on, and never come back to it.
I forgot which section.
151 students are more apt to look at it, give it a good shot, maybe come back to it, but not spend a half hour staring at it. All right, questions?
When you did the foil thing up there, what happened to the middle ones?
All right, so because dot products multiply things that are parallel, if I did this, I dot j is 0, so it really doesn't, I don't have to multiply those. Or I do, but it's 0.
So what you ended up multiplying was just 8.87 times.
Yeah.
Awesome.
We did talk about, I'm pretty sure we talked about dot products in here.
Yeah, a little bit. Look at the
And once it is spoken, I assume all of you know it instantly, because that's the way it works.
However, we do talk about it later, you know.
Yes, we did. All right, so in the little bit of time we have remaining, let's talk a little bit about lab grades. And we don't need to broadcast this.